Welcome to Computer Aided Analysis Lab. Myself, Mr. L. Karthik, Assistant Professor, Department of Mechanical Engineering, Hindustan College of Engineering and Technology, Coimbatore. And my mail ID, karthik.make@iz.ac.in. In this session, we're going to discuss about structural analysis on cantilever beam.
Welcome to today's session. In this session, we're going to discuss about ANSYS analysis in experimental analysis of cantilever beam using ANSYS 19R1 software. So, for our academic, we're going to analyze the structural components in a static structural mode and harmonic analysis, modal analysis and thermal analysis. The first experiment, which belongs to stress analysis on cantilever beam. So let me start with the preference. So we need to select the structural analysis, then OK. Then second one, preprocessor, element type, add, edit, delete. We need to pick this option. And here a dialog box will be appear where we need to select add, and now we're going to select the beam element. Since it is a cantilever beam, we're going to select the beam, and for our application I'm going to choose 2 node 188, then OK, then close. For beam element there is no need to add real constraint value, so skip this step, real constraint value. Then we move on to the material property. Here we need to add the properties of the material by selecting material models, structural, linear, elastic, isotropic. Then we need to enter the values here. So usually for mild steel 210 e power 3 R2 e power 5 and 0.26, 0.25 to 3 for Poisson ratio. Then OK, then close here. The next part will be section. Since we are analyzing the beam, so select beam option and we need to incorporate the values here. So common section, and we need to mention the breadth and height, so both as 1. Then apply preview here, then select OK. So you will get the values for the centroid of Z, Y, torsion constant, Ix. Next we move on to the modeling section. So here we are going to choose create key points. By using the key point we are going to generate a one-dimensional beam. Select this option, inactive CS, key point number, choose key point number as 1, and initially the point will be at 0, 0, then apply. Then second point will be 1, 0, apply, and third point will be 2, 0, apply, and fourth point will be 3, 0, apply. OK. So now we get the values 1, 2, 3 and 4. We need to align these points by using lines. Select the line option and select straight line. Pick the node number 1 and 2, and now node 2 and 3, node 3 and 4. Then OK. Now the line is generated. So a beam in one dimension we have created. Why we are splitting this here? We need to apply 3 different loads for this condition. So we are splitting the line into 3 elements. Element number 1, element number 2 and element number 3. Next one is meshing. We need to mesh into this one-dimensional, two-dimensional and three-dimensional element. Then only we are going to apply the loads at the specific points. So select the mesh tool option and see here a global value, global set, and I have selected the value as 5 here. And if you want to divide the element division, you can make over it to any number of values here. Then OK. Then now choose this option mesh by selecting one by one, then apply, Okay, now the element is meshed, so it will be looks like a complete straight line. This color indicates the line or the beam is meshed. Next, now the part of this preprocessor is over. Generally, there are three steps. One is preprocessor, solution, and post-processor. The preprocessor holds the maximum part. Now we have completed the preprocessor. Next, we move on to the solution. Then analysis type, new analysis, static. It will be defaultly static. Then OK, define loads, apply, structural, displacement. Here we need to arrest one end of the beam and another end should be load will be applied. So I am going to select the key points here and select the left side key point and apply. See here different options are there, all DYF, UX, UY, UZ, ROTX. So I am selecting all DYF. Since it is a static structural analysis, we need to arrest this portion. So all DYF, DYF means degree of freedom. We are going to select this. Once we select this all DYF, here X, Y and all the directions are arrested. See, it is fixed now. Next, we are going to apply the force moment on key points. Since we have split the element into three, node 2, node 3 and node 4 defines the key points. So select the key points and pick here. The node 2 will be selected, apply. Direction will be downward direction and force is minus 200 and apply. The next, select the another line, apply. Value given as minus 300, apply, and the final load will be last key point. There we need to give 100. Okay. Now the downward forces are acted, minus 200, minus 300 and 100. So three different loads are acted. Now the most of the part is completed. Let's move on to the solution part. So solve current LS. See here. Okay. Evaluating the given steps. Once all the steps are correct, the dialog, the message box will be shows that solution is done. Once you receive this message, then only you are doing a correct analysis. Then select general post processor, plot results, deformed state. See, select here deformed plus undeformed, apply. Okay. It shows the deformed beam as well as undeformed beam. Then contour plot, nodal solution, DYF solution, then OK. Then finally we can get the results. So this will be the result what we have obtained for the displacement vector sum. So all the loads at 2 minus 200, at 3 minus 300 and on final load it is 100. So we can get the solutions like this. So thank you. We will see you in the next class.